Our next speaker is Dr. Sudarsana Poojari, and he received his PhD from Washington State University in 2013, and he's currently a postdoctoral fellow with Dr. Tom Lowery and Jose Urbes Torres at the Agri-Canada Summerland Agriculture Development Center. And there's a number of different people that are acknowledged on this presentation, and I'm going to let Sudarsana give the affiliations of the people, but they're from across Canada. Thank you.
All right, so I'd like to present the current status of grapevine red blotch virus status in Canada. I would be talking about the current status of red blotch virus in BC. In my first 8 or 9 slides, and then I'll give a brief information on the status of red blotch virus in Ontario, other province in Canada where the wine grapes are grown. Before going to the details, I would like to thank Dr. Wendy and her team for sharing their data from Ontario to be presented along with ours, and I'll be presenting that as well as towards the end of my talk. First, the British Columbia grapevine industry is the second largest grape production in Canada, next to first being the Ontario. And here is the map of BC showing major grapevine growing regions in starting from the Okanagan Valley, the Similkameen Valley, Fraser Valley, as well as the Vancouver Islands on the left. In BC, white and red grapes are grown at almost equal levels, covering more than 10,000 acres, where the most of wine grapes are grown. Although hybrids are confined to northern and parts of Vancouver Island and Fraser Valley, we grow 97% of wine grapes with whites and red varieties in almost equal ratios, which represents more than 300 wineries, and most of them are located in the Okanagan Valley. Before going to the details of red blotch virus survey, I would also like to mention that this project was initiated in 2013 by the team involving Dr. Jose, plant pathologist, Dr. Tom Lowery, entomologist, along with Dr. Pat Bowen, Dr. Carl, and Kevin Wisher, who are the viticulture enology scientists at Summerland Research and Development Center, which is previously known as Pacific Agriculture Agri-Food Research Center. This 2-year survey is done in collaboration with Dr. Mike Rod and Anna Maddy at Canadian Food Inspection Agency at Saanich in BC. One of the major objectives of this multi-directional projects was to record the incidence and distribution of major grapevine viruses in the commercial vineyards of BC, as the previous national survey was conducted in 1994 and 95 season by McKenzie et al. Where they looked only at 4 different viruses, including rabies mosaic virus and fan leaf and a couple of leaf roll viruses, that is leaf roll associated virus 1 and 3. So since then, there's been a lot of changes in BC wine grape industry. As you can see in these 2 figures, the industry has shown a rapid growth in terms of grape production, acreage, as well as number of wineries in these years. A brief history: the wine industry in BC saw a dramatic change since 1990s. As you can see in the picture, there was a time we had around 1,375 hectares of grapes were grown, most of which would not play a role in the growth of new quality standards that were being adapted at the time. And then starting from early 1990s, vineyards were removed in a significant number and replanted with the high quality wine grapes. So that with that, in 2009 marked our 20th anniversary of the pullout program, and today we have a reborn industry which is emerged and having more than 400 hectares planted with the best quality world-class grapevine varieties. Although the major varieties are shown in this picture on the right, there are more than 60 different varieties that are being used in BC VQS wines. As I mentioned earlier, one of our objectives was to check the current health status of commercial vineyards in BC. So we have undertaken these large-scale surveys during 2014 and 15 growing seasons to record the incidence of major grapevine viruses in the commercial vineyards of British Columbia, which is including the grapevine red blotch associated virus. So what we did here is first we collected the random composite samples from selective blocks. Thanks to Dr. Pat Bowen for providing these GIS maps. These two are the similar maps, and the left side, the map shows the wine growing regions of the Okanagan Valley as presented in the red dotted areas. On the right side, the same map with the locations of blocks where the random composite samples were collected as indicated with the pin dots in black color. Although this map represents only Okanagan Valley, we do have samples collected from other regions of BC where the wine grapes are grown. So next, how we did it, depending on the wine size and grower's permission, and one or more grapevines are selected from a single vineyard. As you can see on the left side, map showing how the pattern of a sample selecting strategy was followed. We followed a 4x5 quadrant sampling strategy. We adapted this strategy from Dr. Mark Fuge with their publications where they did in New York, with a stratified regular quadrant distribution for most of our samples. Depending on the block size and location, exceptions were made to the starting row, as you see on the right bottom side here. Starting row where 4 composite samples were collected from the first row to see the edge effect, especially when this particular block is surrounded by other vineyards. The composite samples of 4 leaf samples per vine and 5 samples per sample size, making it to 20 leaves per sample, were collected, and they pulled together for the testing. At this point, we did not prioritize any blocks based on the characteristic symptoms. And further, we isolated DNA from the leaf samples and tested for the leaf roll virus using PCR methods. We also standardized digital droplet PCR, which is highly sensitive and also helps to determine the copy numbers in a given sample. And also, I'd like to mention that we also agree with Dr. Keith Perry, who was mentioning that sometimes it's difficult to find red blotch associated with virus with only testing only with one set of samples. So most often we use 4 different set of primers, and that's one of the reasons we developed the quantitative PCR, which is digital droplet PCR, to see. Especially helps with the low concentration of virus if it is present in sample. So for this survey, most of the for this survey we used the standard endpoint PCR to confirm the red blotch presence. So to make a story simple, I have divided the results into 2 tables based on the years that we have collected samples. Here is the table 1 that is showing PCR test results for samples collected in 2014 growing season. As you can see, there were around 525 composite samples, which represents close to 2,600 individual wines, representing 7 or 8 different red and white cultivars. If you see the presence of positives, we found only one in one block in a Cabernet Franc, which is a red variety, 3 positive samples. So, and we looked into our data and saw that this particular block is a young block, which is 4 or 4-year-old. So, and then most of our blocks, almost all of our remaining blocks were aged more than 10 years. So at that time we decided that probably it will be good to test the younger vines that are being planted in the BC. So we moved in 2015 growing season. Um, we moved into excuse me, as you can see, we find more positives in the younger plant material. Out of 1,475 random composite samples, again, which represents more than 7,000 individual vines, we found only 29 positive samples positive for red blotch associated virus in 5 different blocks. So when I put together these 2 years data for red blotch virus, we tested close to 2,000 composite samples, again represents more than 10,000 individual vines from different wine growing regions of BC, shows that this presence of red blotch is less than 2% of the total samples that we tested. So out of the one of the possible scenario to speculate here is this result shows that red blotch in BC might be introduced through New Year planting material in recent times, and with possibility of the secondary spread from vine to vine. So to further see how the genetic relationship of red blotch associated virus in BC, we also characterize the full-length genome of a representative isolate, which is isolated from Cabernet Franc. And when we did the phylogenetic analysis and compare with the other available full-length genomes in the NCBA Gen Bank, we found that the BC isolate is closely related to NY175 and NY271, which is clade 1 reported from New York. So, and the genome is pretty similar to what was determined earlier, and encodes 3 overlapping open reading frames, V1, V2, V3 on the virion stand, also 3 open reading frames, C1, C2, C3 on the spliced complementary stand. So bottom line here is the red blotch associated virus BC isolate is a sequent variant of the same red blotch associated virus. We are doing further studies to understand the genetic diversity among different isolates and see if there is any genetic variants that exist in natural populations. So to summarize, before going to the Ontario status of red blotch, we found low incidence of red blotch associated virus in BC and vineyards in BC, and we'll continue our studies to further monitor the virus and its distribution. And also, we'd like to study more onto the genetic diversity and see if there is any genetic variance that exists. We also have plans to see how the virus affects the wine growth and quality in BC conditions. So with that, I'd like to briefly acknowledge all the funding sources and also all the team people, the team of people that helped us to complete this comprehensive survey, especially BC wine grape industry as well as CFIA. So with that, I'll shift gears and talk briefly on the incidence of red blotch in Ontario. Once again, I would like to thank Dr. Wendy for sharing this information with us, and the team of researchers, as you can see here, have contributed to this study. So again, the methods are very similar that I have explained in my previous slides. The question asked was to record the incidence of 2 grapevine diseases, leaf roll and red blotch, in the commercial vineyards, both white and red varieties, in 2013 and 2014 growing seasons. So this is what they did. They tested leaf roll and red blotch collected from a total of 40 blocks for leaf roll and a total of 20 blocks for red blotch from different sub-appellations in Ontario. The sampling size and the methods and were very similar to what I have explained in my earlier studies, in earlier slides. So this is where they tested. Most of the leaf roll testing is done at the AFC Wineland Center by stops and grades using the ELISA. And for red blotch, the PCR-based diagnosis was carried out at University of Guelph Pest Diagnostics Lab. So to put together in a summary, these are the results they found in terms of percentage of infected panels in respective blocks. As you can see, they found out of 20 blocks that were tested for red blotch virus, 7 of them were found positive in different percent infections, which out of 2 were less than 20%, and 5 blocks were more than 50%. Although these are composite samples, red blotch virus incidence was found in Ontario vineyards, and I'm sure there will be further studies in progress, and we'll hope to hear more on the coming seasons on the status of red blotch virus in Ontario vineyards. With that, I conclude my presentation and pass the proceeding to Frank for the next presenter.
Well, I appreciate that very much. Thanks for the update on the status in Canada.